Hey, welcome back, everybody. Welcome to the second part of geometry, or the second lecture of our class. And by now, you should have kind of your idea of what the class is about and go from there. So, according to your table of contents in your notebook, we already been through numbers, number systems, notations, and number line. For the next video, we're going to kind of, get the nuts and bolts out of things. So we're going to do a little bit of algebra review. This basic algebra review is something that you need to have under your belt before moving on, because we will be doing algebra throughout the course. And I want to make sure that you have enough information and enough skill base in order to make this work. Okay, so why don't we go ahead and put this in our notebook and let's move on. Okay, so what we're going to do is we're going to do some basic review questions here for our basic algebra basics. Okay, so I would like you to write this down in your notebook as much as you possibly can, because it really helps you benefit from the long run. So here's kind of what the idea of you need for the basic skills of your math to move on into doing some more geometry. So for example, we need to start solving the basic equations, because those are very logical operations. So go ahead and write these down. And I have a few here that you're going to be doing. Okay, and you can stop this video to do them yourself before you see the answer. But I'm going to walk you through most of these, and I just want you to kind of get a feel about, hey, what algebra that I need here. So on the first one here, I'm just kind of zoom in here. What we're going to do is follow this one. So I'm going to think about what variable. When it says to solve, I want you to think about like a balance beam. So you know what a balance beam is that you get on one end or the other. Maybe you have a person here and you have the same person here. The same person, so or equal person. And what this should do, this should balance. So this is going to be a balance. Okay, it has to be balanced, right? It has to be balanced to make this true. In order to do this, we have to understand that we got to solve for the unknown, which is m in this case. So what we're going to do is do some manipulation. We're going to solve and see what value that makes this 9. Okay, you can probably do this in your head. I don't want you to do this in your head because, one, I want you to know how to do it, because they get worse, and also they get, I want you to check your work as well. But you can probably do this in your head. Yes, you can. But I don't want you to do it in your head. So let's do it. So we got 9, we got 7m, and then what I'm going to do here, I'm going to think about, can I do anything right now? I can't do anything to this side, but I can do some of this side. Well, that's going to be +1 minus 5. Cool. Now, I need to get this m by itself, but it's attached to 7m. So according to the -5, to get this to be to the other side, so like this is like a river, I want to add 5 to both sides. What I do to one side, I do to the other side. I can't just let this leave without substituting something in for it, okay? So this is going to be 7m, because the 7m doesn't change. And then you're going to go 9 plus 5. You can use your fingers if you have to. I think that's 14. Just making sure. Yep, that make sure. Okay, next thing. I want to get just not, I don't want 7m. I want 1m. I just want a single m. If you think about it, this is 1m. Okay, so let's think about this. How many 7s go into 14? And you're going to say, I'm hoping you're going to say 2. So the equation is 2. Now, if I were to, I'm not going to do this to every single problem, but I want you to think about your checking. So if I go into check my work, you remember that balance beam I told you about? This side should equal this side. So I want to make sure that this is equal to 9. If I plug in 2 into this guy, and if I just go ahead and do anything with this, which is -5, correct? Now, if this is still 9, this is still 14 minus 5. 9 equals 9. It balances out. It checks. And that's the algebra that you're going to be basically doing, okay, with equations. So I would like you to always check your work, because it helps you see the logical operations, so you're not wrong, but maybe you made a mistake. Okay, so I'm not going to do them on everything because of the time we have. So let's do a couple more. Like I said, you might have to stop this video do some of these yourself. For example, look at 2. 2 is an interesting question that a lot of people might miss. A lot of people might say, okay, well, can't I distribute this? In the idea, yes, you could distribute this. Now, that is probably not the way that I would go. And here's why. Because then if you distribute this, so for example, if you distribute this, you're going to have this and you're going to have this. And what are people scared of? Fractions, right? They're scared of fractions. So we could do that. We could do that. However, why don't we just get rid of this 1/2? Why don't we just get rid of the 1/2? And how do you do that? Well, why don't we multiply both sides by not just -2. And if we do that to both sides, if we multiply both sides by -2, a negative times a negative is a positive. And so that would be 3x plus 7 on this side. That would clear this fraction. That would clear this fraction. Because what we did what we call the reciprocal. We took the reciprocal of a fraction, which is its opposite, which is 2. Now, I know what you're probably thinking, shouldn't it be negative, positive 2? No, not necessarily. It depends. But think about this. What you do to one side, you got to do to the other side. So if I multiply by -2 to get that fraction away, I got to do this. I got to take 4 times that -2, which is going to be -8. Now, there you go. So that's kind of the idea to get rid of a fraction. You could do it the distributive property, right? You can do it this way. I don't want to do that because I want to kind of make sure that this is kind of working. So there's your thing. I would just get rid of the parentheses because they don't really mean anything. I would just go ahead and subtract 7 to both sides. Subtract 7 to both sides. So you got -8 minus 7. The 3x is here. We want to think about this is minus 15. Minus 15. And I don't want 3x's. I want 1x. So I'm going to divide by 3, divide by 3. Or you can sit here and say, how many times 3 go to 15? And you're going to say -5. Now, I could check this, but let's do a little check real fast. What is 3 times, that's -15, right? Plus 7. Multiply that, hit 4. Very easy check. And I would highly suggest you write it down. But if you can do it in your head, I think that's great. But what if I wanted you to show me on a test or something like that? Then I want you to show me on a test, okay? So let's do maybe number 3 here. Number 3 says, okay, looks like we're going to let n be 4 this time. Okay, so we have a value for the n now. I want to solve for a. I don't know if you know what this is, but this is actually we're going to learn about this. It's called a polynomial or a polygon. And this is kind of like the equation of a polygon to get you how many sides are in a polygon. We'll redo that later. But anyway, this might come back up. So if I let n be 4, solve for a, well, it's already solved for a. So I can just go ahead and go a equals, isn't that 4 minus 2? 180 over 4, right? All I'm doing is wherever I see an n, I'm plugging 4 in. And it looks like I'm solving for a. And I hope that you see that a is the only variable there to solve for. You don't have 2 different variables here, because that's a bad thing. So area equals that. Now, a lot of students would, hey, what if I can subtract? No, you can't do that. It's kind of like order of operations, but backwards. So what if I subtract this first? Isn't that 2? So what is 2 times 1? 140, 180. Isn't that 360 over 4? Right? Because 2 times the 180 is half of that is 360. You're still dividing by 4. How many 4s? Now, here you don't need a calculator. Just take the 0 away. And how many 4s go into 360? 90. So area is 90. How do you check this? Well, let's check this. What is 90? What is if I put 90 here and solve this for n, it should be 4. Now we can do that, but just because of our time, we're going to skip that. Okay. Okay, the rest here, like 4 and 5, we haven't talked too much about, but you might have a little trouble with number 4, and here's why: because variables are on both sides. Don't be afraid here, because remember, I want to get the same variable on one side or the other side. It doesn't matter. The easiest way to do this is that I'm going to leave it this one here, and I'm going to go ahead and subtract 3m here. If I subtract 3m and bring it to this side, how many m's do you have? You should have m, right? Or 1m. What got left over here? -4. And there you go. Okay? So you remember, you always want the variable, you always want to be alone. The variable to be alone. Don't forget that. It's a loner. All right. Number 5, like I said, it's the same thing. I'm not going to do it because of our time, but I hope you can do that so you can stop this. All right. Why don't we do a little bit more algebra based, but let's do something with expanding or expansion. Now, I hope you remember the FOIL method. So this is called FOIL, or maybe you've heard about the box method. Now, I don't care what one you do, but you got to be careful how to do this, because what this is, everybody, this is a 2 by 2. Now, when it's a 2 by 2, you can do it that way or do it that way. When it's a 1 by 2, let's say it's a 1 by 2, you can't do this method. It's just a simple distributive. It's a simple distributive. So be careful. So this has a 2 by 2, which is a binomial times a binomial. Okay, so we got to be careful how to do this. Now, a lot of people love the FOIL method. A lot of you like the box method. I'm going to show you both, but I'm going to stick to the FOIL method because I like it better. You can pick the box method if you prefer. It's the same thing, by the way. You're going to see that just in a second. So let's do the FOIL method. So the FOIL method says if I take my binomial on both sides and I go first term, if I multiply the first term, don't I get x squared? If I take the outer term, which is 3 times x, but I have a positive 3x, and I take the inner term, which is this one, and I multiply those together, you get minus 2x. And if I take the last term, which is this times this, I get -6. Now, I hope that you see that there's x squared here. X squared cannot be doing anything because it's a different exponent power. Now, 3x minus 2x, can I combine those? If you don't like them, take the numbers away. And how many x and how many of these x's and how many of these x's you can have. So isn't that +1? -6. That's it. That's all you got to do. Now, what if I like the box method? It takes a little bit more longer, but it's actually nice. So you get this, you get this. And what you do, here's a little multiplication. Now I'm going to take this side and I'm going to go ahead and put it like this. You see how I did that with the the x and the -2? And then I'm going to take this one, I'm going to go up here. And then I'm going to go x plus 3. Okay? So you see how I did that? Now, what students do sometimes is that they mix these numbers up. And I highly say don't do this. This is why I don't like this method so much, because it can happen. You always want to take these two and usually put them down here, these two and put them up here. Some students have been trained that can I take these and put them over here, and I take these and put them over there. That is okay. That is okay. But I highly suggest just stick to one way. So how to do this? Multiplication. So like a Punnett square, like in biology or chemistry, right? So this times this is x squared. This times this is 3x. This times this. This times this, 6. Now, what do? You take all the boxes and you go x squared. Can I put these two together? Sure. That's positive x. That, you see the same thing? Cool. like I said, either method, you might want to review this. I think this is on my channel about the box method. I think you can find it there, or the FOIL method. I do have a lot of review videos on this stuff. You can go ahead and do that. Okay, this one, I hope that you see the difference here, but you see how this one's a little bit different than this one. Now, a lot of students would not kind of freak out here, but what do you see here? It's not a 2 by 2, it's a 2 by 1. And so what do we say about 2 by 1? When we say 2 by 1, I think it's on one of these sides, is that, right here, it's called the distributive property. So this is a 1 by 1, or a 2 by 1, doesn't matter. I'm just going to go ahead and just distribute. So if I do that, this is 2x to the third. This is going to come over there, which is going to be actually plus x to the what? Fourth power. Do you see why it's to the fourth power? Because back in exponents, when you multiply them, you add them. You multiply, you add them. Okay. Now, since we expanded, expand means make bigger. So expand means this stuff. See how they're much bigger? What we're going to do is we're going to factor, which we're going to go the other way. We're going to take this and go to something like this. We're going to take this and go to this. We're going to factor only. Okay, we're not going to solve yet. We're going to factor. So here's the idea. Stop this video and do it. But a couple ways to look at things. I hope that you're a good person, that you learned a lot about factoring. But it's a struggle for some of you. Just keep learning. Okay, so first thing is how to approach this. To approach this, what you're going to do, I don't know if you remember the diamond method. There's a few ways of doing this, but I think students learn it this way. If you like do like a little X here, and what happens, you see like there's a 1 right here, by the way. Do you see there's a 1x squared? Well, you can still use this way. Here we go. So what we're going to do is to take this number here, which is a 1, imaginary 1 here, and then times that by this. So what do you get? If you multiply that, you get negative 18, correct? If you multiply those, you get negative 18 because there's a 1 right there. Okay, this middle number is a 7. That middle number is there. It's just 7. Now, what we're going to do is that we want to try to pick two numbers that multiply and add to 7. So here's what I mean. Let's take negative 18. If we take negative 18 and say, okay, what two numbers make negative 18? And you're going to say, what about 1 times 18? I know there's a negative in there. Let's just get the numbers first. That make 18. Isn't it 2 times 9? Okay. Let's see, what else? What about 3 times 6? What else? Geez. 4, does 4 go in it? No, 4 doesn't, 5 doesn't, 6 doesn't. Okay, 6 times 3. Do you see how this repeats now? We've gone too far. What we want to do now is find what two numbers added together make 7. Well, obviously 1 and 18 added together don't make that. What about 3 and 6? If you add those two numbers together, you do not get 7. You get 9. It looks like those are our candidates. So I know there's a negative there. Let's just start with this first. We're going to take these two numbers and we're going to place them, kind of get a different pencil here. And if I place those 2 and 9 there, I get 2 and 9. Now, what you're going to think about is say, okay, 2 times 9 is 18, but it's not negative 18. Okay, so here's the question for you. If I put these two together, I got to also make 7. So I have a question for you. What if I have this one or this one be negative? Now, you're probably going to stop the video and do this, but what I want to do, remember this, is that what if I make this one negative? What if I make this one a negative? Negative 2. Let's see. Negative 2 plus 9 is 18. Check. Negative 2 times 9. Oh, sorry. Negative 2 plus 9. Okay. Never mind. Check. Okay. We did it. So what I want you to do now is I want you to take this, and you probably learned this again. some other way, but that's okay. Let's see, I have that one, which I didn't do. Now, what if I take this number and put it there? And what if I take that number and put it there? And what if I take negative 18 and put it there? By the way, do you see what I did? If you didn't, that's okay. What I want you to do is review this. I do have my videos on this, but do you see how these are just those with X's? What I'm going to do is that there's 4 pieces. What if I split this in half? And if I split this in half and I take a GCF, the GCF of x minus 2. Correct? Is that correct? Because if I take a GCF, I have x squared and x. If I take the largest amount out, I get x minus 2. Okay, what can I take out of here? What number can I take out as a GCF of both of these? I can take out a 9. You see that? Okay, what do you have left? X minus 2. Do you see how these two are the twins? Identical twins? So these two are identical twins. X minus 2. Do you see how these are the GCFs? X plus 9. Done. I know what you're saying. I had a teacher that said, you know what, if I had a 1 right there, I can just take these and be done with it. You're right, and Ryan, the only thing that bothers me about that, and I'm not trying to be mean to the other teachers, is that you have to be careful, because the only time you get to do this, the only time you really get to do this, if this was not 1. If this wasn't 1, you would have to do a kind of like a bonus feature, I call it. Don't steal that. That's mine. It's called a bonus feature. Okay. So here we go. So that's that bonus feature. Okay. Now, I want us to look at this one. And I want you to kind of compare here, because these get a little bit, factoring is not everybody's friend here. And that's just how it goes. Okay. What I want us to do is think about how would we approach this? Is this a quadratic? It is a quadratic. We can see that because we have x squared. That's called a quadratic. Now, is it descending order? Is it descending order? Sure. So here's the idea. If I were to do this, I can do that same method that I had here. Or could I take a GCF? Yes. GCF of this, and this. What can I take out of 18, 12, and 8? The lowest number I can take out is 2. Okay, and is there anything higher than that? What about 9? 9 doesn't work because 9 only goes into 18, but not 12. What about 3? Well, 3 doesn't work because 3 doesn't go into 18. What about just 2 then? So what if I just take out a 2? And if I take out a 2, what is left over? Well, how many 2's go into 18? 9x squared. How many 2's go into 12? 6x. How many 2's go into negative 8? Negative 4. Okay, what I want you to think about is that I want you to kind of think about this GCF. This is your GCF. This is the leftovers. The leftovers is what we're going to play with. We're going to put this one on hold. We're going to hold this one because it's really just it's kind of what we put out on it. It's kind of like it's kind of like on the back burner somewhere, like you're cooking, you put on the back burner. We're going to focus our attention on this one. Like I said, I'm not going to finish this problem because of our time right now. I want us to kind of just do this. So if I make my diamond and I went 9 times this, which is going to be 9 times that. Is that negative 36? I think it's so. So that's negative 36. And then I have 6 right here. Now, what two numbers make 36 but add to 6? I think that's right, 1880. So that's 36. 1, 36, 2, and is that 18? Okay. Does 3 go into 36? Isn't that going to be 12? Just make sure my math is right there. I do believe that's right. And let's see, what else? What about 4? Well, yeah, 9 times 4 or 4 times 9. Is any of these numbers working? That's not working. That's not working. That almost works. That almost works too. So here's what I want to kind of think about this one. What if we didn't find, what if this didn't work? What if this did not work? What if it did not work? Do you remember what you would do? You have to go to another method. And that method is called the quadratic formula. Negative b plus or minus the square root of b squared minus 4ac over 2a. And that kind of get you started is that, remember, this is like your a, this is your b, this is your c. So I would like you to kind of do this on your own. And if I'm going to just set it up for you, and I can give you the answer, but that's that plus or minus the square root, that's 12 squared. This is 418. This is negative 8. And then this is 2 times 18. It looks miserable, but it should work out really nicely, I'm hoping. Do you need a calculator for this? I'm just kind of walking through. 2 times 18, let's see, that's 36, isn't it? This is minus 12, plus or minus, what is 12? 12 times 12 is 144. So that's 144. And then this is kind of where it gets a little bit bad. So I'm going to put this as a question mark. So I want you to finish this, and I can give you the answer as well, okay? But I mean, this is just an algebra review. But we will be doing maybe some of this too as we come up to it. But you can't forget some of it. Okay. So the last thing we're going to look at today is functions. Now, I hope you remember what a function looks like. A function is kind of like, here's my number, here's my thing, it kind of goes in there. There's like a little funnel, and here's like the machine, and the machine is kind of like, here you go. And then what pops out is like the y. Okay, so here's the input, here's the process, here's the output. Okay, and so this is what a function is. This is how you would read it. This is f of x, f of 1, f of, this could be f of 1, f of 2, f of 3, okay, where x is the input of the function. And that's what this is. It's like a thing. You can kind of review this. I do have that on my website as well. But a function, remember, is a relationship. For every x input, you get one and only one y output. Now, if you remember this stuff, it's called the vertical line test, where if you think about a function like a parabola, that if you take a vertical line and go like this, for every x, you get a y. So for every time this line crosses, every time this line crosses, every time this line crosses, there's always one x for one y. Okay, that's what a function is. You might want to review this. It's on my YouTube channel. So what if I had this information here? So basic function. So a lot of people, sorry about the glare there. A lot of people think about this. If I say, okay, what if I have a function, and what are functions used for? Where do they see them in real life? I want you to think that maybe I borrow that much money. I borrow $100. If I borrow $100, you're borrowing money. You are owing money. You are in negative territory. And let's say you made an agreement. You made an agreement with somebody who says, you know what, if I borrow $100 and there's no interest, let's just say there's no interest. This is kind of nice. So no interest. And they say, you know what, every week, I want you to give me $5. I want you to give me $5. For what I want to figure out is how many weeks until I pay the debt off. Now you can do this in your head. Maybe you can do this on a calculator, but I want you to think about what's a function, because they can get a lot harder than this. So the idea with this is that you're going to kind of make a little system like this. So if I let X be 0 weeks, 1 week, 2 weeks, 5 weeks, 10 weeks, you're going to get some values here. And what if I wanted to figure out how many weeks will I pay this thing off? So what you're going to do is that you're going to take 0 and you're going to plug it into there. This is the same thing. This is just saying, hey, f of 0, f of 1, f of 2, f of 5, f of 10. Now, I'm just picking these values because I'm trying to give you some numbers to play around with. But if you plug in 2, what's 5 times 2? 10. So what is 10 minus 100? That's 90. So you have $90 left after 5 weeks. If I plug in 10, 5 times 10 is 50, minus 100 is 50. That means I have, after 10 weeks, I still owe 50 bucks. What I want you to do is think about, hey, what happens, how many weeks are there without doing all this work? So what if I say, okay, what if I let the output be 0? So if I let the output be 0, I can go ahead and solve for x. And I'm going to do this. I'm going to take this and plug this over, and I get a 5x. And then I'm going to take 5 and plug it into 100, which I hope you're going to say 20 weeks. So in 20 weeks, I will pay you off. That's a function. For every input, I get 1 output. I don't get 2 outputs. For 0, I don't get 2 outputs. That doesn't work. Okay, it doesn't work. So for every input, I get 1 output only. For every input, I do not get 2 outputs. That's not a function. Okay, kind of to finish this video off, let's make sure we kind of know how to write an equation, because writing equations are always hard for people to understand too, because it's kind of one of those things is that we don't have enough practice, and as you go up the math ladder, you're gonna start doing this. Okay, so what I want to do is write a linear, or write a line from between 2 points. So remember how to do this. If you're going to go on to into other math classes, you need to do more of these. So here we go. One is y equals mx plus b. Next one is y equals mx. Oops. There you go. What this is, they are the same thing. It's just a little bit more easier to work with this one. This one is actually easier. And here's why. Why is this one easier than this one? Because sometimes you gotta solve for b and then plug it back in. We're gonna use this one. This is called a point slope form. This is called point slope form. We're going to use a point slope form for this because we're trying to write a line. This is a line, right? A line is just that, okay? A straight line. So we want to make sure that these are straight. A straight line. Okay. And the reason I say straight line, because technically this could be a line. That could be a line. But it's not linear. Okay, but this is not linear. Linear means a line. Okay, there's for your information there. What I want you to do is write a equation between these 2 points, 3, 4, 8, 9. Now, what I could do is graph these points for you. So if I were to graph these points for you, 1, 2, 3, 4, 1, 2, 3, 4. Here's 3, here's 4. Okay, that's that first point. So this is comma 3, 4. If I were to graph this, here's 8 and 9. It's between it's those 2 points right there. If I were to graph, if I were to graph these 2 points on a Cartesian coordinate system, what I want to do is find the equation of this line. I want to find the equation of this line, and to do that, we need to find the slope. So slope is our what? Is our m, okay? And do you remember how slope goes? It's y2 minus y1, x2 minus x1, right? Or what is it? Rise over run. Okay, so if we do this, first off, we want to be careful how to do this. This is going to be 9 minus 4. This is 8 minus 3. If I subtract those, and if I subtract those, I think that's 7, 6, 5. Is that 5? Yep. So what is 5 over 5? 5 over 5 is 1. So what's the fraction? So the slope, which is m, is 1 over 1. It's always, by the way, your slope is always a fraction. Okay. So here we go. We got this idea. Now what I want to do, this is called a point slope form. Do I have 2 point? Do I have 1 point here? Do I have 2 points? I have, but I need 1 point. So what if I pick this point? So I'm going to pick 3, 4, and then I'm going to use my slope of this. Okay, because this is called a point slope form. And all I'm going to do is plug it in. I'm going to plug it into this equation. So y 4, this is y, equals slope, this is just a regular x, minus x1, which is 3, and there's my equation. Now what I want to do is solve it for y. So if I solve it for y, I'm going to have 1x minus 3 plus 4. Now this is your equation. If you want to distribute this equation in there, you get x minus 3 plus 4, and then you what? At y equals x plus 1. And there's my equation. This is my equation. Now, I understand that might look a little bit terrible. Like I said, I have a YouTube channel that you can, or YouTube video on this that you can watch. I highly suggest that you go through this video again. I know it's kind of long, but that's usually how it's going to happen sometimes with these videos, because there's a lot of information in a short amount of time I'm trying to give you, because I know that you want to get done with this very fast. But like I said, these are videos for you to have and to rewatch them. Okay, but that's the idea of what we accomplished today for the algebra review, and I'm guaranteed that you're going to see a lot of this throughout this course in geometry. Okay, have fun. Thank you very much.